Hi everyone, have a great day. Today we have to talk about a programming concept called Knapsack. It's also an algorithmic concept, and it is the concept based on the real world scenarios. So we will discuss this topic along with code. I'll write the code for you at the end, and we will use for that first of all recursion. So first we should have to solve the problem using recursion, but first and foremost I need to have a problem statement for you, that what the statement of this problem, what's the statement of such a algorithmic problem. So of course we have to go on the, having such a definition of Recursive, and before we dive into the detail of this Knapsack problem, of course there are so many types of Knapsack problem, like 0-1 Knapsack, and the famous ones I will discuss here, fractional Knapsack. But for the moment I will explain you the topic of 0-1 Knapsack. So this should be called 0-1 Knapsack. Afterward we will come to have the grasp of fractional knapsack in the coming videos, but for now I will limit my work over here. So the problem statement of the knapsack problem is that the knapsack problem is a classic optimization problem in computer science and combinatorial optimization. For example, in combinatorics, we should have to, as I already told you in the previous video, we should have to find the number of ways of like in unique part I have discussed it in detail, number of ways to reach from one point to another. So it was a unique part problem, and I discussed it in detail. But for the knapsack, we have to understand the problem statement of 0-1 knapsack, in which we should have a backpack like this one, and this is the backpack, and we put items into this knapsack. So basically the knapsack is a problem of the optimization problem, where the goal is to select items to maximize the total value while staying within a given weight capacity. So by staying within a given weightage or the capacity, we have to put the item that for example it should not be overloaded, and it should load the weight. For example, 12 kg is the total weight accommodated in this bag. After 12 kg we can't have the full capacity to we can't have enough capacity, so our program stops here or less than this. And for this we have to select those items which has the maximum price. So we will our result should be, it's just explanation. I will give you more elaboration in the so what I was talking yes, a result should be the maximum profit. How can we maximize the profit of as a whole of the Recursive? So the returning result will be the maximum profit of Recursive. Which items were selected? So the algorithm, if we understand it, then it will explain that how can we maximize the values or the profits in this Recursive using individual items. So for the moment I should have a formal definition of Knapsack. For example, we have a set of items, item 1, I1, I2, I3 and I4 dot 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 up to some extent like IN. So these are the items and each with weight. So this item should have a weight like WT1, WT2, it has 2, WT3 and so on. Up to weight N. So we will determine the number of each item to include in a collection so that the total weight is less than or equal to the given limit. Like this is the limit, 12 is the limit, and it should be the capital W, and for example this is 12. So the weight capacity should not be greater than this one given here. So and the total value should be value or maximum profit should be as large as possible. So how can we make it possible using recursion? So there should be a mechanism that we have to explain it furthermore, but you know, there are two main types of operation as I explained, 0, 1 and fractional. So we have to focus on the knapsack 0, 1 knapsack problem, in which we should choose an item as a whole, not the fraction of item. Like you know, if the weight of an item is 2, so we should not use 1.5. we should select the item as a whole. If it is 3, we should select 3 as a whole. So this is the concept behind a 0, 1 knapsack problem. So up to now what we have learned is just the conceptual definition of a knapsack problem, and this is a classical. From this problem there are 6 other programming concepts generated, and they are similar and have the total resemblance of knapsack, but we will learn it in the coming videos. For now we should have to explain only knapsack using recursion. After that we will turn the code into memoization, in which we will optimize the running time of knapsack, and moving on, going to down to tabulation, and in tabulation we will see that how can we omit the recursion process and put it into a table, like you know, in memoize. What is memoization? Memoization is basically, let me just a brief explanation of this. Recursive calls plus table. So this is the table. we should create table for optimization like this. Mm, and recursive calls plus table, we store the instant value in a cell of the table, and avoiding the repetitions of overlapping calls, we should select from the already stored object in that cell, so or in this memory. So we should reuse it again to avoid the headache of memory overflow or running times complexity. So first of all, so this was the concept of memoization, but we will come to this in the next video, memoization. Then after the second video, we will come to the by explaining the tabulation method, in which we will omit recursive call or recursion, and we'll just only use the tabulation through loops. So this was the basic concept that I was trying to explain to you. So now comes the algorithmic level of study of the knapsack problem. So here we go. So for example, what we were discussing is knapsack. Let's hurry. So for example, if a knapsack should have a weight, so weight of each item, we should declare here the array, and this is the array of weights, in which the weight should be stored of each individual item. So the weight is the property of item 1, item 2, so it should have the property weight, and against each weight 1 2 3 4 5, so it should have a length of 5, because I have declared 5 size, so the size of this array is 5. So again, it should have a value like this. It should also have the length 5, 1 2 3 4 5. So for example, 2 3 5 8 10, these are the 2 kg first item, 3 kg second item, 5 kg the third item, up to so on. And the value of this is, for example, 45, 90, 8, 10, 6. So these are the values, and the weight, the total weight of the rucksack, like a rucksack is this, or knapsack. For example, it is 11 kg, so this is an integer 11. Okay, so we have to find out the maximum value by considering that weight of each item combined is not greater than 11, or weight of each item, every item, any item, weight of any item is not greater than this. So we should have now a recursive call for this. How can we write the function in C++ programming? We can write the function like this is the return type, integer knapsack kn or ks. Knapsack ks is a function, ks, and here the integer weight wt is array is passing argument, integer value like this. Weight is this, integer weight, and n size. Now for example, from the start we have to define the base condition, because we are defining a base condition because we will recursively call the function and again until the maximum profit 11 is achieved and the bag is filled. This bag is filled when you go to the shop or to the market, to malls and buying something, and you have to to find the bag as a maximum capacity, a maximum value. If you want to choose the maximum capacity, how can you fill that bag? By choosing the items to obtain the maximum profit. So no, sorry, maximum capacity, not maximum profit. So if in shop there is no item, so can you achieve this weight? No, not. If there is no item, then n is equal to 0 and there is no value because there is no item. So, or if there is no weight of an item, if for example the weight of a particular item is 0, so obviously it should have, if weight is 0, then the result will be null, the maximum profit will be 0, so there is no result. So we have to put it like this: if n is equal to 0, or this is r symbol, so n is equal to 0, or w w is equal to 0, return 0. So the result is 0. So this was the base condition that defined. Or if the size is reduced by recursive call, and when it reaches 0, it will return 0. So, or the weight is reduced enough to become 0, so it should return 0. Else, in else part, for example, we choose the for example there are 3 objects, and this is 2, this is 3, and it has 5 weight. So these are the weights of these objects: WT1, WT2, WT3. We should choose it, we should not choose it, or should choose it. We choose it or not. The same is like this: we can choose it, cannot choose it. We can not choose it, we can choose it. So here is the decision made by this choice diagram. So for example, either we choose 5, so we choose it, we selected it. If there is no possibility to choose it, we don't choose it. This is a choice diagram. So for this we will return the result as efficient, as a efficiency, that whether the item should be chosen or not depending on its value. So this was choice diagram that was made, and if I want to clearly explain this, for example, here is an item whose value is 45. We have the decision to choose this item or reject this item. We should include it in the result, or we should exclude it from the result. So this depends on the choice that would be made by using the recursive calls and applying the correct formula. However, we should want the maximum, the limited weight with maximum profit. So we will go to this point, and you will understand when I write here. So else, if the size, the weight of each particular here is 2, if the weight of an individual item, else if weight of n minus 1 is less than or equal to the weight, to this weight, the weight of this 2 is less than or equal to this weight, yes. So if yes, then this is the W, and this is the individual weight, individual item weight. This is a single item weight, you can say it. Then what we should do, we should use the choice diagram whether to include the item or not. For this, we will code it recursively like this: return what? Return maximum. So this is the maximum function. This will decide the choice of the item to be selected or deselected. So max, MA, max, I should write it for you to understand. So what we have to increase the profit. So value, this value, this is the array, the value of the particular item we are choosing now. So this is the code of choice, plus we have added this using the recursive call. Now we should recursively call this function, this ks knapsack. So ks, okay. Now we have to write each and every argument. Here is what? WT. Write WT, comma. What's next? Value array. These are the arrays. This is the particular value or price of the item. You should keep it in mind. Okay, so stick around. I'm just, making a haste. So W. So if we choose the item, we know that the W is, the weight is reducing, the weight is diminishing, So if we choose this item, the weight is diminished, and the weight required is 11. 11 minus 2, it becomes the weight, the W for the moment being is 11 minus 2 is 9, so it becomes 9. So W minus, this is the dead W. Okay, so this is the total capacity of the rucksack, the knapsack or rucksack. So we have filled this item here. W minus what? WT, of weight of the particular item like this. So weight of the particular item is n minus 1 for the time being, comma what's next. N value has changed, so n minus 1, the size has changed. The size becomes, here was 5, now the size becomes n minus 1 like 4. So n minus 1, we should have to calculate for the n minus 1. The 10 has gone. We are in recursion, we always start from the bottom up or start from the end point to the starting point in recursive calls, not from the starting point to the end point. So this is the basic dilemma of recursive calls. So else part is very simpler one, and here we write if else if the weight of an item, like if the item is 5 or item is 2 or 3 or 8, the weight of n minus 1, any item, is greater than 1. The weight, for example, here was 15, so if it was 15, then it should be called, this function should be called, this else condition should be called. So in our function, okay, so return, what should we have to return only okay, I was missing here something. We have selected this, that's why the W has changed, n minus 1 has also changed. These two changes applied when we select the item. Comma, if we don't choose, we have chosen it, so this is the choice of including the item, and choice of the excluding the item is from this comma ahead, like this one, Knapsack, ks the name of the function, and what first argument wt, second is value, third is w, capital W, and n minus 1. The n minus 1 is only decreased here, or it is changing instantly, it is changing, because if the value is not chosen, the side should be shrinked, but the value should remain the same, not chosen. So this is the code of whether to choose it or not. We don't choose item, no choice, don't include, no inclusion or exclude, we exclude the item here, and from comma, the first one here, we include the item price or item value. Here include profit or price, here include no price, no profit. Here we include the profit, price, or you can say the value, but here we exclude the value of profit or price. So this was, if now we come here to this point, if the weight of an individual item is greater than W, return simply this one, ks, reduce the size of the array, and weight remains the same, n minus 1. So this is also a recursive call. So 3 recursive calls are taking place here. The one is this, the second, and the third, and this is our recursive function. So did you understand? So this was the recursive definition of the code, and this was the code. So this was the Knapsack problem, and I hope you understood it very well. So now as you have I have had this code written for you, so a bit of explanation of this code is required. Over here I am explaining it in brief. So for example, this is the weight and this is the value. This is WT array, this is the value array, and total weight of the of this bag is 4. So this is the value of total weight that it bears, this rucksack bears is 4, and here 2, 8, 4, 99 and 8. No, so here we should have to explain it like for example, this is a here we have to choose the item or not. So this was 8 here, and we have to choose the 8 or not. So the individual item weight which is required for is exceeding the limit, so we don't have to choose it, and we should minus it here. So now we come here and check whether the 4 is greater than this weight. This 4 is greater than this weight which the rucksack could accommodate or equal to. So this is not greater than but equal to. So what we have to do, we have to run this this part, this else if statement. After that we return max value is what? 99. So 99 is put in the rucksack. Now the 99 is put into rucksack, and the function calls itself, and total weight is 4 minus this 4. It is subtracted from the total capacity of the rucksack. So 4 minus 4 is 0. Now the code backs again to the recursive call, and now the n is over here like n is n minus 2. It was n minus 1, now n minus 2. And n minus 2 we have to check if n is equal to 0. No, weight is equal to 0, yes, so it returns the result. So the maximum price returned, it was quite easy example, was 99. So this is the basic code against the maximum profit achievement. So the maximum profit achieved by the recursive calls. Now please subscribe my channel, and don't forget to hit the subscribe button, as well as like my video and share it with friends and family. Up to now, goodbye, see you in the next video. Thank you.